everybody, welcome to Tornado Titans. My name is Rachel Center, and today we're taking a look at SatSquatch. It's one of my favorite apps of all time. You can look at satellite imagery, but not in like these static images. You can pinch, scroll, zoom, you can do all the things. So many options too. There's also mesoanalysis in this app, and today we're gonna go top to bottom. Complete tour of this app, all the options, what they mean, how you can use them. I'm really excited about this. So without further ado, let's get started. Let's tour SatSquatch. Okay, I just hopped in the app. It's right there. You cannot see it. There it is, right there. And so you just hopped in the app with me. Let's take a look at all the options. The first thing you're gonna notice is there is like 3 squares in the very bottom right-hand corner. Well, if you tap it, that's where all the options come up. You have so many options. First off, you see Ghost 16, you see CONUS, most likely. I think those are the defaults. So you click on Ghost 16, you can see there's also Ghost 17, which is the satellite that is located further west. Used to be you had Ghost East and Ghost West. Now you have Ghost 16 and Ghost 17. Why would you use one versus the other? Well, if you're going to look at West Coast weather, Ghost 17. If you're going to look at basically plains to East Coast weather, Atlantic, etc., go to Ghost 16. Now, there's a couple of other options up there at the top too that we can take a look at. First off, though, you can see here the band itself. Like the viewpoint, especially on 16, goes from the middle of the Atlantic all the way back over here to the Pacific coast. So you can see the whole country when you look at it. So that's something to keep in mind. But let's go back up here. You can see there are a couple of other options. If you want to take out the CONUS view and you want to have full disk view, well, suddenly a whole lot more of the globe opens up. You can see a lot more all the way from the coast of Europe and Africa, and you go all the way out here to almost Hawaii. That is a lot of viewing, okay? Now, when you get to the edges, the images are going to be a little bit more distorted by nature, like it's lower resolution, etc. So keep that in mind if you're wanting to look at weather just off of the European coast or something like that. You also have the mesoscale zooms. Now, why are the mesoscale zooms important? Well, first off, they offer you these smaller areas to look at. Another thing they offer, let's loop it really quick, and you can see how the timer here in the bottom, it's going up minute by minute. Mesoscale sectors give you a minute-by-minute satellite view. Amazing for storm season, because almost always the mesoscale views are going to show where the severe weather risk is today. At least one of them is going to show that. Look at this. We got one mesoscale view on the hurricane down here in the Pacific, and if you loop it, it's a minute resolution. Back in the old days, I'm just letting you know how special this is. Let's not take this for granted. Used to be you had to wait 20, 30 minutes to get a satellite image, and now we can get them every minute. That is amazing. When you're wanting to dissect like how a Q field's doing and you get minute updates, really, it's amazing. So you have all these viewing options. Let's go back. Let's change it back over to CONUS, and we're going to keep it on Go 16. That's the one I pretty much exclusively use because I'm not a West Coast person. But, so, let's take a look at some more options. You click on those 3 squares again. You see you have visible, infrared, derived. Then you go down here to mesoanalysis. You have to subscribe to the premium to get the mesoanalysis. Well worth it, though. Highly recommended. First recommendation, subscribe to the premium version. So, let's take a look. You have visible, you have blue visible, and you have red visible. Now, you're probably wondering, because if you look on the surface, you're like, what's the difference? They look very similar visually. Well, the blue spectrum basically looks at the blue piece of the visible spectrum, red spectrum, otherwise, practically speaking. The blue would be something you would look for things like visibility products, fog, air particulates, that sort of thing. The red, on the other hand, is what you would use for literally everything else. When you're looking for severe weather, red. When you're looking for snow, red. Storm systems, red. The red visible spectrum is the highest resolution product from the GOES satellites. So I can't say it enough. The red is what you'll be using almost exclusively, and it's great quality stuff. I mean, I'm sitting here scrolling around, not even talking about how you can scroll, pinch, zoom. You can do all sorts of things to change your viewpoint. And I'm a big fan. I mean, as always, I'm a big fan. These are things that I really want to stress. Like a few years ago, especially before this app, you were stuck to like sectors. Like you can view like this region, but if you want to like include just a little bit more, you can't. But now with SatSquatch, you can. Amazing, right? So let's talk about the next bit of this app. So next up on our tour through SatSquatch, let's take a look at the infrared bands. First off, you have shortwave window IR. Why would you use infrared bands to begin with? Well, let's talk about that for a second. The sun allows you to see clouds during the daytime, right? Well, when that sun goes away, you still want to see satellite images, right? You still want to see how storms are doing, etc. Well, when you want to do that, you need infrared. So when we're looking at infrared imagery, that's one of the most practical uses. When the sun goes down, you still want to see storms, you still want to see clouds, infrared's where you want to go. Now, a couple of other things, like with shortwave window IR, a couple of things that I really like using it for. I'm going to scroll over here to California, Washington, Oregon, see if I can see it. Doesn't look like might be covered by clouds, but you can actually identify wildfires really easy with this app. Whenever you're looking, it would be a dark spot on this, especially dark spot wildfire identification, something I use shortwave window IR all the time for, especially in that like February, March, early April period where wildfires are really running rampant over the plains. So you can use it for that. Also, just nighttime cloud identification. I mean, it's a very practical, obvious use. Now, we go on to the water vapor imagery. And the water vapor imagery is something, it's just a classic thing that has been used for years and years and years to dissect jet stream features, short waves, troughs, etc. Like here, you got one here just over California. That's actually the one that's moving out along with this stuff here in southwest Southern California. Gonna be moving out on the plains, causing severe weather. I mean, honestly, you're watching this video long after this was recorded, but just so you know, you can see all the atmospheric features in water vapor imagery. We're going to need to go over how to use water vapor imagery in particular, but you can see here when I go to mid-level, very similar. It just allows you to see jet stream features, short waves, troughs, etc. Big fan of using it for that purpose alone. Now, you go to Legacy Window IR. Why would you use Legacy Window IR? Well, a couple of reasons. First off, I think it allows you to see more of more features within the infrared spectrum, cold cloud tops like iced over, that sort of thing, ice particles. Gives you a really good view of that. For instance, a usage I would use this for is at night. An MCS is rolling through and you're trying to dissect, is this storm still strong? Is it still pushing up tops way up there? Use that in conjunction with radar and you can really dissect like how an MCS is going or how the supercell at night is going. It allows you to see all these things. Again, there's so much to cover here. We don't want this video to be 30 minutes though, so just know that you would use that for those sorts of things. Brighter colors mean colder cloud tops, stronger storms, etc. So let's hop over here to the Derived Products really quick. And as you can look, there's a couple of really interesting possibilities here. First off, you have True Color. What is True Color? Well, True Color is literally what it sounds like. It combines a bunch of the different layers that we just talked about to produce a true color image. You can see literally like what it would look like visually. It's just, you know, it's nice. It's a nice thing. I don't really use this, but it is a prettier satellite image. Now, a couple of other things. You have snow/ice RGB. Why would you use this? You would use it to do things like dissect, are those clouds? Is that snow? It allows you to do that during the winter time months. You can actually see some of the snow here on top of the San Juans and such right now as we speak. Day microphysics, RGB, similar type of thing, identifying ice particles, that sort of thing in the atmosphere. Again, like, this is something like I don't use a lot of these products in the derived area. Mainly because I'm more of a severe weather person, and like the winter weather stuff really isn't my specialty and not something I look at much. Also because I'm located further south and winter weather is admittedly not as much of a concern usually. But these all have good uses. Fog detection. Why would you use fog detection? Looks very much like infrared. At night, this allows you to see fog at night. So like if you're a forecaster, you're trying to figure out fog for different things, any number of reasons, fog advisory, looking for airport advisories, etc., allows you to see that. Then you have the visible IR composite, which I am a fan of for a couple reasons. First off, it allows you to see visible satellite first off, but also IR. It's overlaid on top of each other. And this allows you to do the things like see cold cloud tops. Here we're looking at this hurricane again in the Pacific, and you can see the IR is overlaid over the visible. So whenever the cloud tops get colder, the IR will take over and show you that. And it does have the texture and such of the visible. So it's helpful. Especially if you're trying to do things like dissect storm strength during the day. This is not a bad product to use. I rarely use it. I just tend to go visible, but a lot of my forecasting revolves around what is the visible satellite saying. And to do that, like to forecast that way, honestly, this is like a Marvel kind of tease because it's going to be like maybe a year in the future, but whole video coming eventually on forecasting, dissecting an atmosphere with visible satellite. I may actually record it in the field next year, like slowly, gradually throughout the year. So up next, we've looked through the satellite products really quickly. Let's go through mesoanalysis. Now again, these are premium features. If you want these, you have to pay for them. But again, highest recommendation, do it. You're supporting an app that is growing, getting better, etc., but you're also getting something in return that's of pretty good value. So let's take a look at it. Mesoanalysis. The first thing, METARs. Now, this is really helpful for a lot of reasons. Like if you are trying to dissect a dry line, for instance, and here, I'm going to turn off visible IR composite, and we're going to move back over here to visible red, the red visible spectrum. If you're trying to dissect a dry line, something like that, and all that, it would be really easy right here. Another thing you can do is you can kind of analyze moisture, that sort of thing. Like there's definitely some deeper moisture coming ashore here in Texas, those cloud streaks right there, all indicating pretty strong moisture return. You got 60s coming ashore. Those might help fuel some severe weather in the next week. So there you go. The METAR is self-explanatory. Now, if you want to do something like, you can also do like the sea level pressure, and you're also noticing here you can layer different mesoanalysis layers on top of each other. And, you know, if you're doing this, this would be helpful for things like to assess the strength of a surface low, something like that. I mean, I'm going to admit that I don't use that layer too much. I don't know why. A lot of people probably would say that's a mistake. Probably is. But let's turn that off and let's layer temperature over on this. And you can see here a couple of things that stand out to me. You can see the elevation change here in Colorado very quickly from 60s into the 50s into the 40s. And that's because the elevation changed from the high plains back into the Rockies. But, you know, this is also helpful for things like if I'm storm chasing, I'm looking for the maximum area of heating on the dry line, which is oftentimes a favorable place for storm initiation. I would use temperature for that. And of course, dew point. Everybody, why would you use dew point? Well, let's talk about dew point. Like, right? There's so many reasons you would use dew point. For me, obviously, co-locate maximum heating with maximum moisture. Again, favorable spot for dryline initiation. You can see where good dryline pushes are, dryline bulges. It allows you to overlay the dryline very specifically, fronts, etc. So, and also, right now, you can also just kind of chart out best moisture return. Moving back over here into Texas, you can see that. So, dew point, I mean, basic surface, and literally basic surface things right there. Now, let's go over here to thermodynamics. Let's talk about thermodynamics. You have Most unstable cape, most unstable convective inhibition. Ooh, I can't talk today. That's really funny. I can't say it. Convective inhibition. You have most unstable LCL, LFC. You have that for surface base. You have it for mixed layer. So first off, I'm not going to go through all these because they all look the same. What I would recommend is that you use mixed layer for almost everything. Everybody, like mixed layer cape is the thing that takes into account all of the inflow area, everything underneath the LCL. That average parcel is what mixed layer shows. It's also more indicative of like how unstable the atmosphere is, how capped it is, etc. So I would recommend that. I would recommend using that for all severe weather. 0 to 3 kilometer cape. Now, this is a big deal. If you're looking for tornadoes and you're trying to discern between two targets, pick the one with the higher 0 to 3 kilometer cape. More unstable low levels, more chance of a tornado. It's kind of a cheat code. Definitely do it. You have 0 to 1 kilometer. This is terrible. You have 0 to 1 kilometer lapse rates, 0 to 3 kilometer lapse rates, and then you have 3 to 6 kilometer lapse rates. Why would you use these? Well, let's talk about it. These allow you to kind of do things like see like how unstable the mid levels are, that sort of thing. This can help dissect like possible hail size. We're learning that there are other factors like strength of low-level shear, etc., that lead to like, is there going to be hail today? Versus also like how big it's going to be. We're kind of learning this in real time. New stuff coming out. Cameron Nixon, love you. Amazing scholarship being introduced to the scientific community right now. But I am a big fan of the lapse rates, 0 to 1 kilometer lapse rates in particular, and 0 to 3. Those kind of help you see where the greatest heating's going on, where the most highest temperatures might be later in the day, those sorts of things. Wind shear. Let's go over to wind shear. Let's talk about it. There are five products here. 0 to 1 kilometer SRH, 0 to 3 kilometer SRH, that stands for storm relative helicity. 0 to 1 kilometer SRH with the mean wind, same 0 to 3 kilometer, then you have effective SRH. Now, let's talk about these. First off, 0 to 1 kilometer SRH, you're looking for values over 100. This means an atmosphere is more and more favorable for tornadoes. This is a very easy way to determine how favorable is the atmosphere today for tornadoes. Anything over 100, you're starting to get more favorable. It's like becomes a thing. 200, 300, 400, that's when you're talking about the big days. So 0 to 3 kilometer SRH, what are you looking for? You're looking for values over 300. Those are more favorable for supercells when you get over 300. And again, just like 0 to 1 kilometer SRH, the further away you get from 300, the more favorable an atmosphere is for supercells. Now, this doesn't mean you read this blindly. You have to look at all the possible scenarios. You got to know what the hodograph looks like. If you have you get really gnarly 0 to 3 kilometer SRH readings with northerly winds. Does not mean you're going to get a supercell at that point. You're not going to get a supercell if it is very cold and you have a lot of 0 to 3 kilometer SRH. So this is really helpful when you know there's a dry line, there's a warm sector, all other things are equal, there's severe weather possible. That's why you would use this. So and the mean wind basically takes the mean wind throughout the atmosphere, does the same thing, same rules apply. So when you look at effective SRH, why would you use effective SRH? Again, this is to discern tornado potential. Higher the better on effective SRH. This plus 0 to 1 kilometer SRH are really good discernible factors for like tornado potential over an environment. The higher values in an environment, the more favorable it's going to be. I personally use it to where I match the highest 0 to 1 kilometer SRH with the highest effective SRH. That kind of gives you like, go here. And when you overlay that with the 0 to 3 kilometer SRH, so the ultimate tool to find tornadoes, I think. if you're going to set up something. 0 to 1 kilometer SRH. Let's overlay that with effective SRH. And then let's go over here to thermodynamics and 0 to 3 kilometer CAPE. Now, this can get very, very messy. But when you see all these values overlaying each other, that's tornado time. That's where you want to go. I mean, it's not foolproof, but that's one small way to check out where's the atmosphere really setting up for good tornado potential. Now, there's another trick. Let's turn all these layers off, and you can go down here to Composite. Supercell Composite allows you to see the most likely area where you can see a supercell. So, you have the significant tornado parameter, STP, which is the same thing, but for tornadoes. These are all composite indices, which means they bring a lot of things into one thing, calculate it up, and spit out the result. Now, violent tornado parameter. This one, I think, is the most useful of these because this one has been shown to be very indicative of where tornadoes could happen, especially strong ones, especially violent ones. This one is like, I really use violent tornado parameter a lot because whenever the values on it are just maxed out, I really feel like there's a good chance of seeing a tornado today. So I use violent tornado parameter all the time. So now that we've taken a look at all the meteorological options right there, let's take a look at a couple of other interface things. I've already done it, but you can loop everything just by simply pushing the play button on the bottom right. It allows you to loop your satellite image. You can push plus, you can do things like identify your location, you can refresh the map, the little circles, that's refresh, and then of course you can share the square with an arrow button. So you can do all those things. Cool, right? Let's go over here, push these 3 bars, you get a whole lot more options. You can, for your map, you can enable state borders, enable county borders, enable major highways. I just enabled the SPC Day 1 Outlook. If you take a look, you can see chance of storms out here in the desert southwest. That's associated with this low pressure center coming out into the open, or into the southwest and into the plains. Very low instability today, so don't worry about that. Not a big deal. You can also, I just did that, you can click on a station, you can get the ASOS reading, all that. Pretty cool. Going through here, enable auto refresh. I think you want to do that. If you aren't a big fan of UTC time, display time is local, and bam, you can see that. You can see like what it is. It's Mountain Daylight Time right now. It's about to be Mountain Standard Time. You can hide the opacity slider. You can change your number of frames. You can change the colors here. Manage your subscriptions. You can link a web account. Also, if you want National Hurricane Center tracks, you can do that. Go down here. You can see major hurricane happening right down here. So, a lot of options. This is a cool app, is it not? Hey, thanks so much for watching. I hope you learned something today. Be sure to subscribe. We have so much educational content on this channel. Be sure to hit that subscribe button. It is still up right there, right now. And hey, download SatSquatch. Subscribe to the Mesoanalysis layers. Follow along with weather. Watch us later this spring when we are out live in the field. You'll be able to chat with us and it will make sense to you. It'll be cool. It'll be a lot of fun. And hey, remember, weather is for everybody. That does mean you too. That's why SatSquatch, it was created for all of us. And you should download it and you should be a part of this amazing community. And hey, we will see you next time.